Hi, Ronak. Thanks so much for joining me.
Pleasure to be here today. Thanks for
Yeah,
having me.
of course. Can you introduce yourself? Tell us your position and where you work.
Yeah, my name is Ronak Shah. I'm our Senior Director of Research here at Shift 5, a defense technology startup based in Arlington, Virginia. I've been here for about 3.5 years now. And my role at Shift 5, I lead our research division that's responsible for cyber threat research and development and generally looking at pressing issues and novel ways to solve them for our nation's weapon systems and transportation fleets.
And can you tell us more about Shift Five? Overall, kind of what all do you specialize in addition, kind of to what you just mentioned about your role?
Yeah, so Shift 5 is a data company providing observability into our weapon system platforms and transportation fleets. So when you look at these weapon systems and assets, fleet assets, they're generally comprised of tens or hundreds of embedded systems. Those embedded systems communicate with one another over what we call serial bus protocols or serial bus networks. And Shift 5 provides a hardware software solution that collects all of that data and then provides valuable insights into that data. Those insights can include things like cybersecurity, sort of as an intrusion detection system, preventative maintenance, or operational readiness.
Okay, sure. And and we can delve into more about Shift Five, but I'd love to know kind of how did you end up there? What attracted you about joining a startup? And you mentioned you were there 3.5 years, but what were you doing before then too?
Yeah, so I've spent my career mostly working with embedded systems, doing offensive cyber research, vulnerability research. And what sort of drew me to Shift 5, or sorry, how I got to Shift 5, I honestly, it was a cold call. But the longer story is I was very interested in sort of the cyber physical domain. uh, the way to kind of view that is, it's kind of the cross section of cyber and how cyber effects can impact systems that interact with the physical world and not just, um, you know, uh, when we think of cyber, we typically think of just ones and zeros, but how can cyber effects impact the actual physical world? And so when I stumbled upon Shift 5, I was actually working on a project at the time in the cyber physical domain, and I thought it'd be a great opportunity to join sort of at the ground floor. And I was really fascinated by the domain, and so I figured it was a great way to kind of entrench myself in it.
Right, sure. And you're an EE with a master's in electrical engineering. How did you know? And you that was your bachelor's degree specialty, right?
Yeah.
How did you know you wanted to go into electrical engineering and become an EE?
Yeah, it's a good question. So, growing up throughout my childhood, I was always fascinated by electronic devices. Today, like, I feel like there's been a really large consolidation in terms of, the electronic devices we interact with on a daily basis. Pretty much everything you need to do is done by your smartphone or your laptop, and that's pretty much it, right? But when I was growing up, right, there were purpose-built devices for every little thing, right? You had a digital camera, you had, all these different devices that had their own sort of like custom function. And so I was always fascinated, always collecting those kinds of things and figuring out how they worked. Um, I also, growing up, I was always sort of the person around the house that whenever something electronic needed repair or something broke, I was always kind of fascinated to see, if I could, make it work again. And so that's kind of like where I got my passion for electrical engineering. And to be honest with you, right, I was always kind of dabbling between computer science, computer engineering, and electrical engineering. But I feel like your teachers and professors can make or break certain subjects. And so honestly, that kind of helped me hone in on electrical engineering as kind of a, you know, a degree path.
Right. And how did you decide that you wanted to continue on just beyond your bachelor's to go into a master's in EE and maybe not do a master's in another field?
Yeah. I think um, I think this will resonate with a lot of engineers, especially when you're, in undergrad, where, when you're getting an undergrad degree in engineering, you're really just scratching the surface on a number of different domains, right? And especially with electrical engineering, like there are so many sub domains within electrical engineering that you can explore. And in your bachelor's, you're kind of just scratching the surface on all of those. And so you sort of going into your third or fourth year, you feel like you know, you learned a lot, but there's a lot more you feel like you can learn. And so, naturally, I was still really curious. I felt like I needed to learn more to really, be an effective engineer. And so, to me, it was kind of a path of either actually pursuing my PhD or getting a master's degree. And ultimately, I decided to just do my master's and then go into industry. And so, right, it was driven by this kind of internal need to wanting to learn more and get a little bit deeper in a particular domain. Just given that, electrical engineering just spans so many different things.
You went to University of Maryland, and I'm excited. I have a cousin who just graduated high school and is going to University of Maryland in computer science. But what was it about the school and what they were offering as far as electrical engineering, either for your bachelor's and or master's, that kind of spoke to you about going to that particular program?
Yeah. Well, first of all, go Terps. But growing up, for me, the decision to attend the University of Maryland starts with being just a really strong Terp sports fan. And so, when we won the national basketball, men's basketball national championship in 2002, that kind of like, definitely more than put it in the forefront of like my vision to attend there one day. But sort of beyond that, right? The University of Maryland's a great engineering institution. Between the research that they conduct and the partnerships and relationships they have with industry, really attracted me to really develop roots there. The other thing that, I was kind of part of my like thought process was, I mean, just the geography of the University of Maryland, right? It's nestled between Washington, D.C. and Baltimore with lots of great work happening, in that domain. And so I was like, there's there's a lot of opportunity, within the geographic limits of campus too. And so kind of forward thinking about, what I would be doing post education, I was like, well, there's going to be a lot of opportunities just because of geographic proximity. Um, so yeah.
Right, sure. And a couple years ago, I was interviewing a PhD student at Virginia Tech in electrical engineering. And he was kind of teaching me about how EE has kind of evolved from kind of the traditional, electrical engineering of circuits. And he really was taking a whole more breadth of computer science. And so he's kind of seeing the field evolve. What do you notice about that, and do you see that obviously in your field and what you're using, I guess, in work? Kind of that meld of computer science with kind of that circuitry.
Yeah. That was extremely apparent to me in undergrad, where, you could get really specialized in sort of circuit design and some of your more traditional electrical engineering domains. But like I was saying, right, it's kind of it's expanded to so many different other domains, like especially with just really looking back, right? Like you've got the advent of computers and such that really kind of broadened the domain and communication systems as well. So I think, as an electrical engineer, I will say there's sort of a fork in the road where you're like, hey, do I continue down the more traditional electrical engineering path and, work strictly on hardware and, or communication systems? Or do I venture down this path of, electrical engineering, but more of it in a computer science, um, you know, uh, focus? And so I definitely chose the second path, right? I think that was a combination of just a combination of my self-interest, but also seeing that, there is a tremendous amount of opportunity there to, one, make an impact as an engineer, right, in terms of innovation and the things that are, kind of up and coming in society, but also just given the geographic proximity, right, of the university, you have all these opportunities to explore cybersecurity, computer engineering, computer science, and that was kind of more at the forefront. And so, that it all just kind of made logical sense to do that. But I think as in general, like I feel like almost any electrical engineer kind of faces this like decision, right? Like, am I going to take my career path down the more traditional route or kind of delve more into like a computer engineering role? Um, so I definitely think that's apparent. I think the trend is going to be you're going to see more electrical engineers head into that space.
Right, and then you've overlaid your expertise in, cyber protection of physical systems. Can you kind of tell us how that evolved and kind of how you keep, abreast of or current, in your fields, I guess, EE and obviously cybersecurity now. How do you stay current with that?
Yeah. So the interesting thing about sort of cyber physical systems, right, is you have the opportunity to blend um, the more traditional computer science concepts and topics with sort of the more hardware engineering realm, right? You get to, let's take a cyber physical system as an unmanned aerial vehicle, right? You get to obviously explore all of the traditional computer science areas, but you also have to develop the understanding of how aerospace systems work. And how embedded systems are designed for those kinds of platforms. And so you kind of get this multi-domain problem that you sort of entrench yourself in. And right, it scratches the itch of your interest you have in computer science. It scratches your itch of core electrical engineering concepts, and then even beyond that, some of the more aerospace or mechanical engineering concepts. And so um, that's what really drew me to it, was that, it's not just the ones and zeros that you get in a more traditional computer science cybersecurity problem, but you get to kind of open up the aperture and look at a lot more things there. Um, in terms of keeping myself relevant, it's such a great question. You know, I've always had this problem of, there's just so much information, there's so many new things that you can learn. And you have a hard time figuring out like where should I spend, you've got a finite amount of time that you can dedicate to it. And, you know, having to choose where exactly that makes sense is, a really difficult task. But, the ways I do that, especially in my role today, where, I'm a little bit less hands-on than I used to be, is a couple different areas. One, I definitely, there are a handful of technical publications that I regularly read to keep myself sort of abreast of the kind of the tip of the spear of what's happening in industry. Two is attending conferences, roundtables, workshops, that kind of thing to, you know, not just see things from the lens that you get from a daily basis, but also see, other perspectives from industry. And then when I do get the opportunity, I do love participating in sort of hackathons and CTFs. It's kind of a great way to, you know, gamify technical work. And so it kind of provides an outlet to get hands-on and do things in that way as well.
Oh, very cool. And then can you talk about GPS spoofing, something that you all are specializing in? What is it what is GPS spoofing? And what are the risks? And then what are the antidotes or the protections against that?
Yeah. So I'll start with GPS jamming. GPS jamming is a little bit simpler to sort of understand and quite frankly implement. So GPS jamming is essentially creating enough RF energy in which you degrade or just completely disrupt the ability for GPS receivers to view legitimate GPS signals. GPS spoofing, on the other hand, is more deliberate. It is actually deceiving a GPS receiver into thinking that it is somewhere where it is not. So you can see how that's a little bit more complex than jamming. We're starting to see the wide proliferation of GPS jamming and spoofing. In fact, there's a working group that we're a part of that where we're seeing a very significant increase in GPS jamming and spoofing around the world, and it's starting to impact many civilian systems, to include civil aviation, which has very large and significant impacts. Shift 5, right? The way we're solving this problem is sort of different than some of the other approaches you see out in industry. Like I was mentioning earlier, we're an onboard observability company. And so, when you look at a particular weapon system asset or a transportation asset, all of these various onboard components are speaking to one another over this network, this serial bus network. And as we're sort of harvesting and harnessing all that data, part of that data is the GPS data that's coming off of a GPS receiver. And so we're analyzing that data to detect when jamming or spoofing is occurring. We can provide sort of a leading indicator of when that happens, or when it's happening before it actually corrupts other systems on board that are relying on that GPS receiver. And so that's really important, from a course correcting perspective, right? If you sort of have, before downstream systems that are relying on GPS are corrupted, you can still salvage sort of the state of the overall system, to sort of deselect or, ignore GPS from those systems. And so that's kind of how we're solving that problem. But I think more broadly, like the way we'll probably see this problem kind of get circumvented is we need to see more resilient position, navigation, and timing technologies. Right now, between mostly with civilian GPS, it's extremely trivial for adversaries to perform jamming and spoofing. And so I think there needs to be, the industry as a whole needs to take a look at more resilient PNT technology to kind of address the issue.
Right, sure. And I guess that can go into, quantum-based PNT or quantum clocks, to have, that secure PNT that underpins everything. And kind of obviously the GPS spoofing, when that happens, detection is so important. You may not know what's happening to a system. Where do you see kind of that ability or detection abilities, or how do you see that evolving, I guess, over the next couple of years? And then kind of You mentioned kind of how you're preventing kind of things on the system, before other things are corrupted, if GPS signals are jammed. I guess how do you see that capability advancing too over the next couple of years?
Yeah, I think from a detection perspective, we I think, it's sort of like a lot of other problems where you have, if you can increase the diversity of data inputs that you have for a detection system, the better the results and of the output of that system, right? And so I think some of the things that we're looking at here at Shift 5, right, to kind of enhance that is what other data sources on board can we use to better enhance our ability to detect. There's a number of things that we can do to get ahead of that problem as early as possible, to give the crew on board, sort of a leading indicator of that problem. But I think even outside of Shift 5, the industry as a whole, right, the way we can look at it is, what sensors can we put, into the field that can give us better understanding of where spoofing or jamming emitters are, right? To understand where and how adversaries are employing these tactics, right? We need to have these sensors out there to better understand those tactics and techniques so that we can build more effective mitigation technology, right? Without that data, without that sort of cognizance, like we're just going to constantly be chasing, our adversaries in terms of capability. And so I think, we need more data to solve that problem. And the way we can do that is with, the employment of better sensors and uh, scale up the amount of sensors we have.
Right, sure. Yeah, it sounds great. Sounds like a well needed defense, especially in great power competition, where countries such as China and Russia are really meddling in space where they hadn't been before with our satellites and other things. Let's see. I wanted to ask you kind of you're in the defense industry, with Shift 5, using your EE skills. Did you think about being in another field other than the defense industry? And I guess why work in the defense industry?
Yeah. Yeah, I think, I've always sort of had a passion for, something that I can do to help our country in general. And, that kind of has a natural, progression or lead into, working in defense. Um, I think, you know, uh, if I were to speak to someone, someone in college today and, who's trying to sort of figure out a path forward and, or who may be interested in defense. I think a lot of times some of the toughest problems that are present in defense, don't often get communicated well. You typically hear a lot of the things that are in front of your face about, consumer technology and just because we interact with it on a daily basis. But when you look at, defense, there are a lot of really interesting, very complex problems and challenges that, the DoD in our country has. And, you know, quite frankly, they're oftentimes way more complex and challenging and interesting than some of the ones we may face in commercial or consumer technology. And so, with that perspective, now having been in the industry for so long, I think that's some of the guidance that I would provide that, given that problem set, the fact that anything that you do, obviously helps, your country and national security. I think a combination of those things is really, really rewarding. You can kind of walk away, on a daily basis and know that you did something that, kind of moved things forward, for your country. And so that's really rewarding.
Right. Yeah. That's a lovely sentiment. It's, to have something meaningful like that. Any future goals that you want to share kind of, and you work for a startup, I'm sure your attention is heavily on that, but do you set future goals for yourself, either personally or career wise?
Yeah, I think I always want, at least for the foreseeable future, want to be, um, solving some of the most critical problems in sort of interesting and novel ways uh, for the defense industry. I think, DoD really depends on small businesses, that are highly specialized and, can solve some of those tough problems for them. And I foresee myself sort of being in that domain and would like to continue to be in that domain, for the foreseeable future. I think, um, there's a lot of impact that you can have, especially at that scale. And so that really interests me. It has always interested me, and will definitely be something I continue to do.
And anything you want to share about challenges along the way? You make it sound very easy with your talents, but any challenges that you can share you faced along the way that you kind of had to overcome in your process?
Yeah, I think sometimes there's uh, you can always find yourself really consumed by a particular problem. And, like whether it's you're solving something for your customer or, whoever, you can really find yourself entrenched in that. And, it's always, it's always good and healthy to take a step back from time to time and realize that, you're not only are you going to help yourself, but you're also going to help sort of whoever your end customer is, by ensuring that you're making sure you're taking care of yourself and doing those things and putting those things first. Um, it's easy for someone, right, who can get lost in sort of all the noise and be in the day-to-day grind that you kind of lose track of that. And so definitely take the time to take care of yourself and definitely do that. And so that finding that balance, right, is always sort of a challenge. But I think over time you start to learn the things, the mechanisms you need to, and really you learn a little bit about yourself and learn when you've hit the point of like, okay, I need to kind of step back, take a step back away from what I'm doing to kind of come back with with a fresh mind. And so I think that's really important, especially as a right if you're working in a small business domain. It's there aren't always all the best incentives for small businesses in this domain, and so you have to work extra hard, to sort of make it. And so, that coupled with just being really passionate about what you do and getting sort of lost in it, it really compounds that problem. And so, you know, that's always been a challenge. Definitely have built the mechanisms to get better at that. But I think for anyone kind of doing that or going into this domain, that's something that you do need to keep your eyes on.
Right, sure. Well, that's great advice. And those are all my questions. Anything else you wanted to share or highlight?
No, I'm good. Thank you for having me. It was great, great chatting. Great to talk about, take a step back and talk a little bit about, myself overall. And so I appreciate the opportunity.
Right, sure. And thanks for walking through all that and sharing your experiences. It's so great. And good luck with your efforts. I know you probably have a lot on your plate. So thanks for taking the time.
Of course, thank you.
Thanks.